Okay, the slide is visible.
Yes, sir.
Yes. So we were discussing about the a very simple neural net. So it is basically can say SLP or singular perceptron, and we are today we'll start the training algorithm. Training algorithm. Okay. So in this okay. So what is the basic idea of the singular perceptron? It is that what we said, that this is the summation unit, and there is some sort of inputs over there. Let's say it is x0, or better to say it's x1, okay, x2 dot 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 xn. So these are actually inputted this function. There is a bias term we set for our understanding x0, and this is w1 is associated with this, w2 this, and wn, and it is w0. Okay, so this is the, so this summation we said d, and this summation is basically putting to a kind of nonlinearity, kind of sigmoidal. Okay, and that is going to the output. So this is the that simple most diagram. Okay, now what is d here? D is basically summation is equal to 0 to n wi xi. Right? And that is basically this d. And what is output? Output you can say let G of t. But G is a sigmoidal. What is G of z? Is equal to 1 by plus e to the power minus z. Okay, so this is the sigmoidal. So this is the more or less idea. Now, what is important that let for simplicity, we say that your this G of Z is equal to Z. So there is no non-linearity over that. So then what is the output? Output is basically this. I is equal to 0 to n wi xi. That means D is output. Okay. Now we have to find out what is, so what actually our setting, as we said, we put the input here, fine, and we try to find out the desired output there. But maybe what will be, this is the predicted output, so we can say predicted output is D, and desired output को हम क्या बोलते हैं? हम ground truth बोलते हैं. GRU, ground truth. what is supposed to be, actually supposed to be. So this is small d. So we can calculate error. What is the error? That error, we can say this error is the square difference. So half t minus d square. Okay. So this is the square difference. Now what we're going to see here, that how actually we going to train this. For that reason, we'll see that this is our weight updation algorithm. So weight updation algorithm is what? Wi, if it is a previous weight, just for your this is the epoch, let's say epoch k. Okay, and then this Wi with the epoch k minus 1, that is the this thing, plus this of w by. So this is the weight change. Okay, so these are the weight we have to change in this way. Now what is Wi? So that we have to be calculated. What is this W? This, sorry, this delta T problem. Wi, that is eta T minus O xi. Now what is T, what is O? That is, so T is the target value, T is the target value, and O is the output value. In our discussion, T is basically is the D, and output value is the D is the your O. These two are two things we have said. So these two difference. Actually, here one, this is what we're going to say, that T of the xi of this, actually what we're going to do, we're going to not, it is not the difference, is the rate of change of this difference. So what we're going to do, we'll say xi. Okay, so that is, and I'm coming, what is this? This is called the learning rate, that we have already seen in case of our uh, the training of linear regression. Okay, it means how quickly we are converging, or we try to converge. Okay, I think you recall these things. That is basically the, can say, that is the one-dimensional error space, or you can say noise space, and this is basically a gradient. So if it is a, this eta is very low, so it is very less thing. It is very slowly coming to this. And if it is very high, then it generally happens this much, that much, then again that much in this way. This, they are toggling, or they are basically randomized. So this is called learning rate. So here also the same, the learning rate. Okay. So here we can see that exactly here also we are trying to do in this way, that Here we try to, this is error E. Okay. Now this error E, we are going to take the differentiation with d of wi. Okay. So it is what? It is d of d, if I differentiating with this, and d of dwi, d minus d, sorry. So okay. So this is exactly the gradient error. So it is very important terminology, error gradient. This is error gradient. That means this. Okay. Now to see that this d, small d, is basically a constant because it's a prescribed output, ground truth. But this is our this thing. So we can say that this part is equivalent to d of dwi of d. Okay, because this is d is constant. This constant is the ground truth. Okay, you can say this is the ground truth. That because of this is the ground truth. Okay. Now if we calculate this is equal to this particular thing. This is equal to dwi, d of dwi. We can, this particular thing is d, so we put it here. Okay, the bias term we neglect. So this is 1 to n wi xi. It's not a big issue. You can put a bias term also. Nothing. Okay. Now you see this, for this particular thing, this is wi. For this particular xi for wi, this for y is equal to 1, it will be x1. W of 2, it will be x2. Otherwise, these things are so all are 0 because it's a different thing. So it is equal to xi. Okay, for any I. So what actually we get, that this energy, that is error, so it's not energy, this is error gradient, is basically d of minus d to xi. Fine, because this is xi, basically this term is xi and d of d of xi. Now ultimate term, this is ij, is your weight, it is our initial weight. Just a second. For your understanding, we should put the k plus 1 iteration. Shit. K minus this eta eta because this particular J is the jth neuron for J, because this is G for this reason this J is coming, because this is kind of jth row and ith neuron. Jth column jth level. So this is updation rule. In this way, the weight are being updated. If you have any question, you can ask. Up to this much we have done. So this is the way we do the weight updation. So it is clear? Fine. Okay, there is some issue. So now slide is visible again, no?
Yes, sir.
Yeah. Okay. So what we have seen that these are the this we have already understood that these are the way we are. Now there is a two-class problem. What if there is a only just we can say the apple and non-apple case. So what I said, that this particular thing what we have discussed, it's a basically two class problem, and this eta I said the learning rate or rate of convergence, whatever you say. Now this is easily can be extended to the multi-class problem. Now for multi-class problem, this wi for all these wi's, the basically that this g of for this multi-class problem. Now for all j not equal to y, those x is greater than all of other classes, that is basically that x belongs to that y. Okay, so that is very important to understand. Okay, so this is very easily to the multi-class problem kind of thing. Here the same thing. Now only thing difference is that multi-class classification, everything is the same. Now this dj minus dj is basically dth neuron. Okay, and we calculate the same thing, only the training algorithm is basically that particular thing. So already we have said like this. Okay, so one thing is important here, that we, so that what we have seen, that it is basically what we have discussed is single layer perceptron. Okay, and single layer perceptron is basically some that, so that it is, if the data distribution or the data is linearly separable, then SLP work. So that is very important, because you see that here this particular thing wixi plus b, this is the linear equation. This is kind of a straight line equation. Okay, so this straight line is a single straight line, is a straight line. So unless otherwise it is a kind of there is a linear, the things are linearly distributed, linearly separable, then this SLP will work. Okay. Okay. Now we are going to understand one thing that is very interesting, that can you implement an OR gate using single layer perceptron. Okay. So what will be the, this is AND gate. So OR gate, what is the, okay, let's say AND gate. So AND gate, not. So what is the truth table of the AND gate? 0 0 0 0 1 0 1 0 0 1 1 1. Okay. Now you see that this is the bias term. this X and Y will be the input, and what will be the W? Okay, so what will be these values? Now we will see. Now if we put that this value, that W is equal to 0.3, so what we are going to say, that X is equal to 0, Y is equal to 0. So X into 0 into 0.5 plus Y into 0 to 0.4, that is minus, that is plus minus 0.3. Okay, and this T is equal to threshold is 0.0. Now what is this? This threshold is, what is this? This is 0 plus 0 plus, so it is minus 0.3. So it is generally less than 0. So output is 0. So this is correct. Now you put 0, 1. This is equal to 0. This is equal to 1. So what happened? This is 0. This is minus 0.4 plus minus 0.3. Again it is less than 0. 0. Now you say this is 1. This is 0. Now what will be happened? This is 1. So it is 0.5 plus this is 0. 0. This is minus. Actually, there is some mistake actually. Mm. So, okay, whatever. This is 0.50 and then it is minus 0.3. So it is minus my point 2. It should be 0, but it is a wrong. This result is not good. Okay. And if it is a 1, if it is a 1, then if it is 1, then 0.5. If it is a 1, then minus 0.4, and this is plus 0.3. Definitely it is greater than, oh no, sorry, minus 0.3. It is less than 0. So then this is also wrong. So this weight, whatever weight you have given, you have to change this weight. Okay. So you can say that output is something like that. You see, this is the out table. Same thing with what they are doing. Here there is a small assumption is that this is okay. So this is the minus 1. This is minus 1 is fixed. Okay. And this is 0 0 0 1 1 0 1 1 and for this AND gate. But here if you say that this is 1, so this particular thing is wrong. Okay, the same thing if it is there minus 1. Okay. Now if you put these values, you can see that this xy and this is minus 1 and this 1.511. Then you can see that, so the previous thing why this example is given, that you have to change, the your weights, you have to change your weights. How are you going to change your weight? Here you can see, now you see here, now this is minus 1, it is fixed, so it is always 1.5 minus 1.5. And if it is 0 and 0, so it is less than 0, so it is 0. Then minus 1.5, if it is 1 0, then it is 1, obviously it is less than 0. 0 1, then minus 1.5, again 1, less than 0. So all these things are 0 0 0. But if it is a 1 1, that means that it is a minus 1.5 plus 2 is greater than 0, so it is 1. So in this way, this is a valid AND gate. Okay. So if I say, can you go for an OR gate in this way? Can you say what will be these values? Can you say the for OR gate? Please do yourself and just see the say, at least somebody say the answer. What will be the, these are the thing. Let's say this is the minus 1, you can put it minus 1. What is the bias? Minus 1. What is W? Hello, is it audible?
Yes, sir.
There is some network issue, that's why I just cut it down. This is the thing. So find the value of W0, W1, W2. Okay. And what is the threshold? Here is the threshold.
Sir, 122.
122 means what? 122? This W0.
Yes, sir. 1,
This.
then 2,
Okay. And what is threshold?
1.
Okay. Let's see. What is OR gate means? 0, 1, 1, 1. Okay. So you see what he said, that is 1, 2. So it is, first of all, it is -1, 0, and this is threshold is 1. So it is 0. Good. Then ये तो दिख रहा है, कोई एक जीरो होगा तो दो दो आएगा. Yes, it is correct only. So any other? So you can understand that. Now, can you do the same thing for Zorget? What will be the W0, W1, W2 and threshold in this setting? What is the Zorget?
Sir, is it not possible?
It is not possible. Any other view? Any solution? So let us try to understand what is saying. This is the why. Okay. Now, what is the Zord formula? What is the Zord formula? X, Y, and Zord. Bolo? 0, 0. 0 1 1 0, ये दोनों 1 है, ये दोनों 0 है, ये तो सर ठीक है. So now you can say that जो x and y दोनों ही जब 0 है, so it is 0. This is 1 point. Okay, I put it in a different color. So this is 1. Here 0 0, this is 1 0, and 1 1 यहाँ पे होगा कोई कहाँ पे, this is also 0 for cross, 1 for plus. Okay, you can change the color. So 1 for plus. So देखो 0 1 0 y x, that is, so this is 1 point, and 1 0 0 1, this is x 0 y 1, this is another point. So this so can you get a single straight line to separate these point data points? This is the problem. So it's simple, not, it is not possible. So Zord, this data distribution is not linearly separable. So this kind of SLP cannot do this. Got, so this is a very, very important observation. Okay, very, very important observation. Now, how many of you not understand why this kind of thing happened? Okay, so at least 2 lines is required. Now the question is, if 2 lines are required, what will be the solution? A single straight line cannot solve it, but 2 straight line can solve it. And what is the solution? Can you say? Any clue? We use at least one extra layer in between input and output. Okay, and ये extra layer को क्या बोलते हैं? Now, why I put so much emphasis of this particular aspect? Because nowadays we are very much interested about the deeper network, the deep neural network. What do you mean by deep neural network? It is, this is input and this is, let's say, output. And there is a lot of layers in between. Dot dot dot. It's a lot of layers. These are called hidden layers. Now the problem that is simple enough that cannot be done by a one single line, that is by SLP, but that cannot be done with SLP if there is a two line is required. So, but if you on extra layer, so this kind of bit complex problem, sorry, can easily be done. Now, if you are going to a very complex problem like face recognition, object detection, image classification, then more sophisticated thing we have to care. So this hidden layer, we're going to have this power to get or to extract more higher order features or higher complex features with higher complexity. Like a face. Face is what? Face is a very complex feature representation. There's a lot of different features which actually, if you say that we are giving you some description of a face, can you draw the face? You have to lot of the description you have to give. So lot of description means what? It was bit subjective, but lot of description ultimately means there is a high dimensional feature space. So if you have to adjoin this high dimensional feature, so very high level feature generation or extraction, we need more hidden layer. And from that point of view, it say from tomorrow's class we'll see tomorrow after mid-sem, when we put the introduction to the deep learning, we can understand this thing very clearly. But this is a very important thing that we actually go after for this. If you have any question, please ask. This is a very, very important. And what is the, you can say, some sort of stepping stone or some sort of basement from the deeper architectures. Okay. Okay. So before we conclude today, regarding learning algorithm, there is a few observation, few things you have to know. What is epoch? Presentation of the entire training set to the neural network. So एक बार पूरा training set हो जाने से एक epoch बोलते हैं. In case there is AND function of epoch consists of 4 set of inputs being presented to the network. All this is the training set, and these are the corresponding values and weights. So this to all input combination, if you complete, it's called one epoch. But it doesn't mean that it is always give you the desired weights to give the to the actual weight for the desired result. So many epochs you have to do. Not even error. The error value is the amount by which the value output by the network differs for the target value. For example, if you require a network to output 0 and it output 1, then error is minus 1. That we already discussed. So we stop here today. Thank you very much.